Hello and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler. Today we're going to be doing Unit 5, Lesson 4 on parts of an algebraic expression. Now in the last lesson we learned a little bit about variables and we learned about what happens when we combine variables with each other and with operations with normal numbers, right? We get what are known as algebraic expressions. Okay? Today what we're going to be doing is kind of looking at algebraic expressions and really just introducing you to some new terminology. That's it. But let's start off with a little bit of a review problem just to get our legs underneath us. Here we go. Exercise number 1. Write algebraic expressions for each of the following using n to stand for the number that is not specified. All right. Easy enough. So for each one of these, I want you to write an algebraic expression using n for the unknown number. Let's do letter A together, then have you work on the rest of them on your own. So letter A just says 12 added to the number, right? So simple. Again, we're using n as the variable here. So 12 added to the number, make sure you've got n plus 12 and not 12 plus n. That would be the number added to 12. That simple. And a great example of an algebraic expression. Algebraic because it has a variable in it, right? We don't know the value of n, or we haven't given you the value of n, right? And it's an expression rather than just a simple variable because there's also an operation, addition, right? Addition by 12. So what I'd like you to now do is pause the video and see if you can come up with algebraic expressions for the other 5 in this problem. Take a few minutes. All right, so the number divided by 8. Remember, we don't want to use the division symbol. We want to use the fraction bar when we have division. This is simple enough. We're just going to have n over 8. All right, let me just bring the screen up a little bit. Letter C, real easy, 3 times the number. Simple enough. Remember, we do not want to use the multiplication symbol because it could be confused with the variable x. So all we have to do is sit the 3 beside the n. Remember, please don't write it like this. That just, I don't know, there's just something so wrong about that. So wrong. None of that. 3n, not n3. All right, 1/2 of the number. 1/2 of the number. This can actually be written in 2 very acceptable ways. One way to do it is just 1/2 times n. So that's a really great way to do 1/2 of the number. But of course, what you should already know is that whenever you multiply a number by 1/2, that is the same as dividing the number by 2. So either one of these is a completely okay way to write it. 1/2 times n or n divided by 2. Exactly the same expression. All right, letter E, the number squared, right? Squaring a number means just taking that number as the base and raising it to the second exponent. So a number squared is n to the second. And likewise, a number cubed, exactly the same idea, except instead of raising it to the second power, we raise it to the third power. So we have n to the third. Great, that's it. Just a little bit of a review. Each one of these is an algebraic expression because they all have variables in them and they all have at least one operation. All right, let's keep moving on. Now, let's take a look at a little bit more of a complex expression, algebraic expression. Exercise number 2. Consider the expression 4x plus 3y minus 7. Letter A, evaluate the expression for x equals 5 and y equals 2. Show the steps in your calculations. All right, simple enough. I'd like you to pause the video right now and figure out what the value of this expression is when we substitute 5 for x and 2 for y. Take a little bit of time to figure that out. All right, let's do it. So I'm going to put the value of the variable in parentheses. So 4 times 5 plus 3 times 2 minus 7. Keep in mind that we must do these products first. 4 times 5 is 20. 3 times 2 is 6. Then we'll do the rest just going from left to right. 26 minus 7 gives me 19. All right, that's simple, easy. The point of that wasn't so much to review how to evaluate an expression, but so that we could get to letter B. Which operations happened last and why? all right? Well, let's just talk about this, right? What happened first? Now, substitution wasn't an operation. Operations are multiply, divide, add, subtract, exponentiate, right? Those are operations. And what came first was the multiplication. What came last was the addition and subtraction, right? Those are the last things we did. We did that addition, and then we did the subtraction. Addition and subtraction. And they came last because they're last in order of operations. Now, because addition and subtraction are the last thing that you do in a mathematical expression, then oftentimes we look at 4x as being a thing, and 3y as being another thing, and the number 7 as being another thing, okay? Those three things, 4x, 3y, and 7, are all what are known as terms, all right? Terms of an expression. Let's talk about the term. That's right, I didn't make a mistake there. The term in the next slide, mathematical terms. A term is a combination of numbers and or variables, because it could be just strictly numbers, but it's a combination of numbers and or variables using multiplication, division, and or exponentiation, all right? So when we combine variables and numbers together using strictly multiplying, dividing, or exponents, or exponentiation, all right, that is a mathematical term. Mathematical terms are separated by addition and subtraction. So if you're ever wondering how many terms are there, is this a term, is that a term, then we simply need to look for the addition and the subtraction. Let's see how that works out in exercise number 3. For each of the following algebraic expressions, circle each term and state how many terms each expression contains. Sorry, I can't read very well. So let's talk about this a little bit. So letter A, 7x minus 8. You can almost hear it in the way I talk, 7x minus 8. So what I can tell is because of this one subtraction, all right, I can see that I have two terms. Remember, a term, right? A term is a combination of variables / numbers using multiplication, division, and exponents. 7 times x is a term. 8 is a term. I know that there's nothing else there, but that's okay, right? So we've got two terms, 7x and 8, right? In letter B, if I'm thinking about how many terms this has, well, I have an addition and addition there. So my three terms are 4x squared, 3y, and 9. So 3 terms. And terms are important, all right? Because oftentimes the way an expression behaves mathematically is somewhat dependent on how many terms it has. How about this? Pause the video now and see if you can answer how many terms letter C has. All right, let's go through it. So this one looks huge, but again, it's easy. I have an addition, a subtraction, an addition, and a subtraction, and that means that 2a is a term, 5b is a term, 3c is a term, the d all by itself is a term, and the 12 is a term. So we have 5 terms. The term. I love it. Anyway, and again, terms are important. Eventually you'll get all sorts of fancy words like a binomial is something that has 2 terms and a trinomial has 3 terms, etc. We're not going to worry so much about that in 6th grade algebra. Let's keep moving on and working with these terms. All right, so the coefficient of a term. For an algebraic term, the number that multiplies the variable, or variables if there's more than one of them in the term, is known as its coefficient. Okay, so it's real simple. A term is a combination of numbers and variables using multiplying and dividing and exponents. Any number that multiplies an entire term is known as the coefficient of the term. And coefficients are really important in sort of the real world of math. So let's look at exercise number 4. For each of the following expressions, do the following. 1, circle each term. 2, write each term separately. And 3, state the coefficient of each term. All right, this is really simple enough, right? If I look at letter A, I've got 2 terms, right? And I know that there's 2 because they're separated by that plus sign. So my 2 terms are 6x, and it's got a coefficient equal to 6, right? And then we have 9y, and it's got a coefficient equal to 9. So literally, if I said, hey, look at this 2-term expression, what's the coefficient on the y variable? You'd say 9. And if I said, what's the coefficient of the x variable? You'd say 6, right? Coefficients are very easy ideas. So what I'd like you to do now is pause the video and write down exactly what we did for letter A, but do it for B and C. All right, easy enough. Again, 2 terms right here separated by that plus sign. So one of the terms is 7x squared, and its coefficient equals 7. And the other term is 12 times x, and its coefficient is 12. The final one, very, very easy. 3 terms, 5x, 2y, and 3z, right? 5x, 2y, 3z. So 5x is one term with its coefficient equal to 5, 2y with its coefficient equal to 2, and 3z with its coefficient equal to 3. Now, I know what you're probably thinking. You're probably thinking, you can't get easier math than this, right? I'm just looking for the subtraction and the addition. Right, I'm taking off the things that are sort of on either side of it, those things he's calling a term, right? And then I look at the number that's sitting in front of him, and that's the coefficient. And that is truly all we really did in this problem. Sometimes, though, identifying the coefficient can be a little bit more difficult. So let's take a look at that in the next exercise. Here we go. Some coefficients are trickier than others, all right? Every single term has a coefficient, whether you see one there or not. And remember, a coefficient is the number that is multiplying the variables, okay? So let's take a look at exercise number 5. For each of the following terms, rewrite it as a multiplication and identify the coefficient. All right, so you might look at this one and go, x, there's no coefficient there, except that we can rewrite x as 1 times x. Right? Because clearly 1 times x is just x. 1 times any number is that number. So 1 times x is the same as x, and then that leads us to conclude that the coefficient here is equal to 1. Any variable that's just kind of hanging out by itself, its coefficient is 1. Now you might look at letter B and go, well, then the coefficient there is also 1. Not so fast, though. Remember, we talked earlier about the fact, I think we had something like 1/2 of n. And I said, well, that could either be written as 1/2 times n, or it could be written as n over 2. This is the same idea. X divided by 2 is identical to 1/2 times x. So the coefficient in this case is not 1, not 2, but 1/2. And again, if it helps you look at it this way. Put a little 1 there, you know. 1 times x over 2, the coefficient is 1/2. That being said, I bet you're going to have no problem figuring out the coefficients of C and D. Pause the video and figure those out really quick. All right. Well, again, if you like, you could always put a 1 in front of that x. This is the same as 1/10 times x. So the coefficient is 1/10. And likewise, 3x divided by 4 is the same as 3/4 times x. So the coefficient is equal to 3/4. So if you kind of get into this geared in mode of, well, it's got to be the number that's multiplying x or n or c or y or whatever, then you might think, oh, the coefficient here is 3. Maybe there's no coefficient here or here. Maybe you wouldn't understand. So you have to really always think about it as, whether there's division involved or not, what is it in terms of multiplying, right? What is it in terms of multiplying? And then it's 1/2, 1/10, and 3/4. Pretty easy. Now, coefficients can oftentimes have a meaning in the real world. And we want to look at one final exercise that kind of gets at that idea. So let's take a look at it. All right, exercise number 6. Kevin is keeping track of how much money he has saved up. He starts with a certain amount of money already saved and puts the same amount of money in his bank each week. He figures out that the expression 3n plus 12 will calculate the amount of money he has saved after n weeks. Letter A, how much money will Kevin have saved after 1 week, 2 weeks, 3 weeks? All right, so this is simple, but just to make sure we really got it, there's lots of words up here. 3n plus 12 is telling us how much total money Kevin has saved up. We've been told that Kevin had a certain amount of money saved to begin with, and then puts in the same amount of money each week, right? And that somehow this expression calculates the total amount of money that he has. Now, letter A is really simple. It just says, well, figure out how much he has saved after 1 week, 2 weeks, and 3 weeks. To do that, we're going to substitute 1 into this expression, 2, and 3. Let's do 1 together, right? This is very, very easy. If I put 1 into this expression, keep in mind, I must do the multiplication first. So 3 times 1 is 3, plus 12. Kevin will have $15 saved up. Right? Surely you can do 2 and 3 on your own, so pause the video now and take a few moments to do that. All right, let's do it. So again, this is sort of the, as I like to put it, same song, second verse. Right, we're going to put the 2 in for n, 3 times 2, we have to do that first, gives me 6. 6 plus 12 then is 18. Right? Then when I put 3 in, I'll get 3 times 3, which is 9. 9 plus 12 is 21. Right? And so, right, that's how much he saved after 1 week, 2 weeks, 3 weeks. Now keep in mind that that does include the amount of money that he had sort of saved up at the beginning, right? So now for letter B. What does the coefficient of 3 on the term 3n represent in the real world? And what does the 12 represent? All right, so we've got these two terms, 3n and 12. Technically speaking, right, 3 is a coefficient, 12 is not particularly a coefficient, although one could think about it that way, it's just a constant. What do those two numbers represent in the context of this problem? Pause the video now and think about this for a moment. All right, well, the 3 is how much money he's putting into the bank each week. And you can tell that, right? Because from 15 to 18, that's $3 more. From 18 to 21, that's $3 more. So the 3 represents the amount he is saving each week. And then the 12. The 12 is what he started with, right? Because ultimately, what's he doing, right? He's taking $3 that he's saving each week and he's multiplying it by the number of weeks he's been saved. So, after 1 week he saved 3, 2 weeks he saved 6, 3 weeks he saved 9, and then he adds that to the amount that he had saved up front, the 12. So each one of those numbers had some meaning within the greater context of this situation. All right, let's wrap this up. So today, we really just learned some terminology, right, about algebraic expressions. One thing that we learned was just what a term is, right? And a term is some kind of combination of variables and or numbers using multiplication, division, and exponents, okay? Terms are always separated by subtraction and addition, so it's pretty easy to spot them. The other thing that we learned about was the coefficient of a term, and that is simply the number that multiplies, not divides, but the number that multiplies the variables within a term. All right, sometimes it's easy to see, like if I have 5x, the coefficient's 5. Sometimes it's hard to see, like if I have x divided by 7, the coefficient is actually 1/7. All right, so play around with these ideas on the homework. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.